This is video 1. We present here the definitions, conventions and notations used for graph. We consider a graph G which represents the two-dimensional discrete plane. The vertices of this graph are couples of integers and represent coordinates of the two-dimensional plane. Vertices are also called positions. Consider a position U which is in dark gray in this example. We denote by x subscript u the abscissa of u and by y subscript u the ordinate of u. The graph G is undirected. The position U is the extremity of 4 different edges. Here are the 4 edges. Their other extremity is drawn in light gray. These 4 vertices in light gray are the closest neighbors of V. In other words, they are at distance 1 of V. In this article, we always consider the maximum norm. From now on, we represent the grid graph as a dotted grid. Edges are omitted. All the other graphs considered in the article are subgraphs of the grid graph. For example, consider the following graph G1. Its set of vertices is a subset of the set of vertices of G. Also, its set of edges is a subset of the set of edges of G. The size of G1 is the size of its set of vertices. In this example, the size of G1 is finite and equal to 27. We denote by lowercase x subscript G1 the lowest abscissa of G1. Uppercase x subscript G1 is the highest abscissa of G1. Similar notations are used for the ordinate. Along the article, we will often need to do some translation of a graph. Consider a vector V. The translation of G1 by V is obtained by translating all the vertices and all the edges of G1 by V. In this example, we consider a vector V which is equal to 6, 2. And now we represent the translation of G1 by V. Note that G1 and its translation share a common position. The translation of G by V is denoted as G plus V. Finally, the union of two graphs G1 and G2 is obtained by making the union of their sets of vertices and their sets of edges. Here we make the union of G1 and its translation by V. We obtain the following graph. Remark that G1, its translation and their union are all connected graphs. In this article we will always consider connected graphs. Thus when we make the union of two graphs, the resulting graph will still be connected. The intersection of two graphs is defined the same way. We consider the vertices which belongs to both graphs and the edges which belongs to both graphs. The intersection of two graphs will always be connected.